Our next section is questions related to large sample test. Just before starting questions related to large sample test, we shall refresh the various tests discussed in the title large sample test. There are four test procedures considered in large sample test. Two tests for population mean and another two regarding population proportion. The first test is test for mean of a population has a specified value when the population standard deviation sigma is known. Now for that we have a statistic x bar minus mu 0 root n by sigma. Here x bar represents mean of the sample taken, mu 0 is the suspecting value of population mean, n is the sample size, sigma is the standard deviation of the population. For the time being, we assume that this standard deviation of the population is known. So the null hypothesis is h0 mu equals mu 0, and we have the various alternative hypotheses h1 mu greater than mu 0, mu less than mu 0, and mu not equal to mu 0. We shall consider them one by one when we come to the construction of various critical regions. Now, in the construction of various critical regions, first we consider the right-sided test where h1 mu greater than mu 0. That is, the null hypothesis is as before mu equal to mu 0, and the alternative hypothesis is mu greater than mu 0, which is right-sided. Here the critical region is t greater than t alpha. That first t represents the value of t using this equation and calculated based upon the sample mean and sample size and also the known value of standard deviation of the population. So if this calculated value of t is greater than t alpha, we reject h0. Now t alpha is the value of standard normal random variable referred from tables of standard normal distribution corresponding to the level of significance. Level of significance is the freedom offered for rejecting a true hypothesis. Based upon this freedom, this probability for rejecting a true hypothesis, we set this t greater than t alpha. That is, t equal to 0 if x bar and mu 0 coincide each other. What is the meaning of x bar and mu 0 coincide each other? The sample mean has full support to the suspecting value of population mean mu 0. But sometimes sample mean may be little bit greater than the suspecting value population mean. Even then we are ready to accept population mean is mu 0. So up to which level we have to accept this population mean mu 0. That is decided according to this significance level. Here this shaded sector represents the critical region and its size is determined based upon this freedom for rejecting a true hypothesis. That is, if this is the area 0.05, it means that probability for rejecting a true hypothesis is 0.05, and this is the point where this T alpha and T alpha to infinity is the rejection region. So if the value of T appears between T alpha and infinity, we reject at 0. That means that we are ready to know is an x bar and mu coincide each other. That is the perfect agreement between sample mean and population mean, and we are again ready to accept population mean as mu 0 whenever the value of t lies between 0 and t alpha, that is within these two. There also we are ready to accept population mean as mu 0. If it goes beyond t alpha, we say that the hypothesis is not true. That's how we set t alpha, that is t alpha is fixed according to the level of significance. Now the procedure is very much similar to the left-sided test. We simply shift this critical region from right side to left side. That is when when an alternative hypothesis is h0 mu equal to mu 0 and when null hypothesis mu equal to mu 0 and alternative hypothesis is mu less than mu 0, the critical region will be t less than minus t alpha. That means this is the rejection region, and this rejection region has again the size alpha, that is level of significance alpha, and if the value of t calculated from the sample using the same equation, goes below this minus T alpha reject at 0. That means we are ready to accept whenever T lies between 0 and minus T alpha. If it goes less than minus T alpha, we say that it is significantly different. That population mean, no, there is no support of sample mean to accept population mean as mu 0. So we have to reject the null hypothesis. That is when the test is left-sided, that is T less than, no, H1 mu less than mu 0. In the case of two-sided test, the procedure is very simple. We divide the total significance level alpha to equally to two parts. That is alpha by 2 in the left side and alpha by 2 in the right side. And each my point size area alpha by 2, we have the values like minus t alpha by 2 and plus t alpha by 2. We can note that both these points will be equidistant from 0 because the curve erected is symmetric. Therefore, if the value of t is calculated using that equation based upon the sample values is either less than this minus t alpha by 2 or greater than this t alpha by 2, we reject at 0. Therefore, it can be combined using this line, that is modulus t greater than or equal to t alpha by 2. That means modulus t greater than or equal to t alpha by 2 is equivalent to either t less than or equal to minus t alpha by 2 or t greater than or equal to t alpha by 2. So these two separate intervals combined using this single equation or single interval modulus t greater than or equal to t alpha by 2. Now we have the specific values for alpha. When alpha is 0.05 for one-sided test, T alpha will be 1.645. For two-sided test, T alpha by 2 will be 1.96. Likewise, if alpha is 0.01, T alpha will be 2.33. T alpha by 2 will be 2.58. So that completes the construction of critical region for uh, all the three types of alternative hypothesis. Now, the second test in this title large sample test is test for equality of means of two populations. Here we have the null hypothesis mu1 h0 mu1 equal to mu2, where mu1 and mu2 are the means of the two populations. To test that hypothesis, we draw two samples x1 bar and x2 bar are their sample means. N1 and N2 are the sample sizes. And here also we assume that sigma 1 square, sigma 2 square, which are the standard deviations of the two populations, are known. So this is the statistic for testing the hypothesis. We note that this statistic also has standard normal distribution. Therefore, in this case also, the critical regions corresponding to various alternative hypotheses are exactly similar to the former case, because the critical region is according to the significance level, and the significance level is a probability, and that probability is related to the distribution of the statistic we consider. Here in this case also, the distribution statistic is n01. Therefore, wherever we consider large sample test, in all the cases of large sample test, in the same title, the test statistics will be normally distributed, and therefore in all the cases of large sample test, here we consider have the same critical regions for various alternative hypotheses. Therefore here, when mu1 is greater than mu2 right sided test, critical region is t greater than t alpha. T alpha is as before referred from tables of standard normal distribution corresponding to the significance level, and mu1 less than mu2 it will be t less than minus t alpha, and for two-sided test it will be modulus t greater than or equal to t alpha by 2 uh, or or t less than or equal to minus t alpha by 2 or t greater than or equal to t alpha by 2 when you write in two separate intervals. So these are the three critical regions for the three different types of alternative hypothesis. And now we assume that the standard deviations of the population are known. So in the first case, sigma known. If at all sigma is unknown, we will replace it by S. Here sigma is unknown. We replace it using sample standard deviation, and the statistic is again normally distributed. So this replacing sigma by S is valid only when sample is large. So naturally a question arises, suppose sigma is unknown and sample is not large in size, say small. So what do you do? Okay, we can make use of another statistic where sigma doesn't appear in another section called a small sample test. Anyway, for the time being, when sigma unknown, we just replace sigma by s and proceed in the same manner. And this is the same situation when the two population means equality case. Here if sigma 1 sigma 2 are unknown, we will replace them by sample standard deviations s1 and s2, that is sigma 1 square sigma 2 square unknown, replace them by s1 square and s2 square, and making use of the same statistic following normal distribution. So this is the situation for proportion has a specified value. So we have p equal to p0. This is the statistic, and again this statistic follows normal distribution. So the construction of critical agents are exactly similar to the former case. Next is test for equality of two population proportions. Here we have two sample proportions p1 dash and p2 dash. This is for the proportion of first sample, and this is the for proportion of second sample. Now this is the statistic used to test the hypothesis, and when h0 true, yes, here comes the exact equation of statistic used to test equality of two population proportions. Here we have one constant p star. That p star is to be estimated using this equation. So finally, the statistic used to test equality of two population proportions is p1 dash minus p2 dash divided by root of p star q star into 1 by n1 plus 1 by n2, where q star is 1 minus p star, and p star is determined using this equation. Again, note that this statistic also follow normal distribution, so there is no difference in the construction of various critical regions. Now, after refreshing all the four types of test under the title large sample test, we can come to the various questions. So the first few questions are simply related to the terminology and some other principles of testing. We can come to the numerical question from 28 onwards. So this is question number 28. Here we can come to the answer of this question. See, the question number 28 is an electrical manufacturing light bulbs that have life length is approximately normally distributed with a mean 800 hours and standard deviation 40 hours. If test at 0 mu equal to 800 hours against the alternative hypothesis mu not equal to 800 hours, if a sample of 80 bulbs has an average life 788 hours. Here, the hypothesis to be tested is H0 mu equal to 800 versus mu not equal to 800. So that is, there is a belief that average life length is 800 hours. The question is it true or not? To test this hypothesis, we draw a sample of size 80, and the sample mean is found to be 788. So there is a we naturally suspect that the population mean is not 800. There is somewhat difference between 800, say dip from 800 to 788. That's why we suspect mu equal to 800 versus mu not equal to 800, because the question is to test whether mean is 800. So we have given the sample mean 788, sample size 80, and this is a mistake here. This S is 40. It is not S actually, it is sigma, because in the question approximately normally distributed with a mean 800 hours and standard deviation 40. So this 40 standard deviation goes to that of population. There is no statement regarding the sample standard deviation. We are given only the details of sample as sample size and also sample mean. So this 40 is that of sample, not sample, population standard deviation. So we have to read it as standard deviation sigma. We shall correct it. This is not yes, it is sigma. So the equation will be x bar minus, is the fair case, that is sigma known case. So 6 bar minus mu 0 root n by sigma, and this is not valid here. It is true only when sigma is unknown. So you substitute all this, we can find 2.683, and see that this is a two-sided test. Here mu not equal to 800, so it is two-sided test. So at 5% level of significance, we see that the table value T alpha by 2 is 1.96. We can see that it is 1.96 when alpha is 0.05. Therefore, here we reject the hypothesis if either t less than or equal to minus t alpha by 2 or t greater than or equal to t alpha by 2. That is, this shaded sector is one part of the critical region, that is in the left side, and the remaining part of the critical region is in the right side, that is the other side means shaded sector in the other side. So if this is the point minus 1.96 and this is the point plus 1.96, that is in the right side. Now the value we calculated based upon the sample data, it is 2.683. You can see that if this is 1.96, the 2.683 will definitely appear here in this side of the shaded side, that is critical region. So we have to reject the hypothesis. That's what we say. 2.683 is greater than 1.96, hence we reject the hypothesis, which means that the data do not support to accept average life length of the bulb is 800 hours. The sample has no evidence to accept population mean as 800 hours. So next question is, a sample of 36 drinks from a soft drink machine has an average content 7.4 with standard deviation 0.48 ounces. Test the hypothesis mu equal to 7.5 against mu less than 7.5. So we set H0 and H1 as given. H0 is 7.5 and H1 is mu less than 7.5. Clearly this is a left-sided test. And here you note that standard deviation of the population is not given. We are given as the standard deviation of the sample only. So that's why here that side the margin we have written, if sigma unknown, we replace it by S since n is large. Size is said to be large if the number of units examined is more than 30. So this is 36, so it can be treated, you can treat it as a large sample. So substituting all these things, we can get the value of t from the sample as minus 1.25. Since the test is left-sided, we can see that the critical region appears in the left side, and this is minus 1.645. T alpha is minus 1.645. That is the table value for a one-sided test. That is alpha. T alpha is 1.645. So it is minus 1.25. So minus 1.25 will appear like in this side, that is it is greater than minus 1.645, so it will appear this side. So we say that accept H0. Therefore here we say that even though there is a dip of 0.1 from the population mean to sample mean, that is 0.1 is because population mean suspecting value 7.5, sample shows only 7.4, there is a dip, and we say based upon the sample that this dip is insignificant. That is, we conclude that difference is insignificant. You can treat exactly 7.5, which there is no question, no evidence to say to reject it at 7.5. Now next is number 32. A sample of 100 recorded deaths in US during past year gave an average lifespan 71.8 with standard deviation 89 years. And do this indicate lifespan is greater than 70 years. So this is mu equal to 70 and mu greater than 70. You can see that this is a right-sided test, greater than 70. So again, this is a situation where sigma unknown, but we can comfortably replace sigma by S and take the same statistic. So it is on substitution 2.022. So now the test is right-sided, therefore the critical region will appear in the right side, that is here only. Now alpha is 0.05. We can note that T alpha is 1.645. So this is the position of 1.645. That is where from the shading will start. That is 1.645 to infinity. But see that this value calculated based upon the sample 2.022 will appear in the right side. That is this side only. It will fall in the shaded sector, means it is to be rejected, which means that the difference between the sample mean and population mean is significantly different. That is, there is no evidence to accept population mean as 70 years. The sample shows only 71.8 years. The suspecting value of population is 70 years. There is no evidence to accept population mean as 70 years. We have to reject the hypothesis. That's why we conclude sample has evidence to claim population mean is greater than 70 years. Next, we consider a situation of two means equality. That is H0 mu1 equal to mu2. where mu1 and mu2 are the means of two populations. The two populations, one is 800 apples taken from the first population. It has average 190 and standard deviation 10 grams. The second sample has been drawn from another population and its mean is 192 and standard deviation 9 grams. Examine whether the sample, now the populations from which these two samples have same averages. So that's why we set H0 mu1 equal to mu2 and H1 mu1 not equal to mu2. This is not a case to test whether either mu2 greater than mu1 or mu2 less than mu1. We just examine are they equal or not. So we list all the details given. Here we are not given the standard deviations of the populations, but no problem, we can replace them by sample standard deviations and proceed with the same uh, equation. So it is x1 bar minus x2 bar by root of s1 square by n1 plus s2 square by n2. So after substitution, we will get it as minus 4.407. And this is a two-sided test. So as before, the critical region will appear in both sides of the standard normal curve. One side is less than minus 1.96, that is from minus 1.96 to infinity, and other is plus 1.96 to infinity. Or you can combine them together and say modulus t greater than or equal to t alpha by 2. Modulus t greater than or equal to alpha by 2 is equivalent to writing in separate intervals either less than minus 1.96 or greater than 1.96. But note that minus 4.407 will definitely appear in this side, that is less than minus 1.96. So we reject H0. So we can conclude that means of the population differ significantly. So next is a case of comparing these performance of boys and girls, average performance of boys and girls. We take mu1 as the average performance of boys and mu2 as the average performance of girls. So H0 mu1 equal to mu2 is the null hypothesis, and it is to just examine are they equal or not. That's why we take alternative hypothesis mu1 not equal to mu2. List all the details given, and this is again a case of standard deviations of the populations not stated. We are given only standard deviations of the sample. Substituting all these things, we get t alpha, no, t as 3.746. But see that this is again a two-sided test. Therefore, the critical region has two sections. One is in the left side and other is in the right side. And we see that this 3.746 will be greater than 1.96. That will appear this sector. That is, this is the position of 1.96. 3.746 will appear this side only. That is inside the shaded sector. So we reject H0. So we say that the performance of boys and girls differ significantly. So based upon the data, we say that the data doesn't indicate that the population mean the performance of the boys and girls are same. So again, one more case of testing equality of population means here the two samples taken from two populations. We have the sample means, sample sizes, sample standard deviations. As before, two-sided again, that is mu1 equal to mu2 versus mu1 not equal to mu2. List everything, and this is again a two-sided test. So again, critical region has two separate sections. One is in the left and other is in the right. The value calculated will be uh, the value calculated is minus 3.431, and minus 3.431 will definitely appear in this left shaded sector because this is minus 1.96. This is the position of minus 1.96, and this is, I'm sorry, this is not minus 1.96 here. The question is at 1%, two-sided at 1%, that is alpha 0.01. Therefore, there is slight difference in the table values for 1%. For alpha 0.01, T alpha by 2 will be 2.58. That is 1.96 is when alpha is 0.05. So it is 2.58. So we have to compare it with 2.58. So that's why here I do the comparison with the T alpha by 2.58. However, that is greater, mean minus 2.58. So this value minus 3.431 is less than minus 2.58. So we reject H0. Again, minus 3.431 appears in the left side shaded sector. So means differ significantly. Next, our aim is to test proportion has a specified value. So here is a candidate at an election claims that 80% support for him. So to examine this, he take a sample of 400 voters and he got 300 likes. 300 likes, 300 supported the candidate. So based upon this data, can him accept the claim 80%? There is slight difference in his claim and the data. Uh, so is it true to accept the claim is 80% itself significantly different or not? So we have the null hypothesis p equal to 0.80 and alternate hypothesis p not equal to 0.80. So it's again two-sided. So the statistic is p star minus p0. That is, in case of that proportion, p star minus p0 divided by root of p0 and 1 minus p0 by n. So we substitute this p star, p0, p0, q0 by n. P star is the sample proportion. So in the case of this 300 voters out of 400, total 300 supports from out of 400 voters, the sample proportion will be 3 star p star equal to 300 by 400, that is 0.75. Substitute, we get minus 2.5. Again, this is a two-sided test. Here this is t alpha by 2, 1.96, and see that minus 2.5 is less than minus 1.96, means the value of t calculated using the sample lies in the left side of the two parts of critical regions. So we uh, reject the hypothesis. Therefore, we cannot say the claim of the contestant is not true. Okay, the claim cannot be true. Now, next is again a case of testing proportion has a specified value. For 80 males and 520 females were born in a week. Do this figure confirm the belief that boys and girls are born in equal numbers? So we take if equal numbers, p equal to 1 by 2, proportion of boys and girls in born in a week equally, so it is 1 by 2, and it is not equal to 1 by 2 because the question is to examine whether boys and girls are born equally in a week. So either equal to 1 by 2 or versus not equal to 1 by 2. So it's again a two-sided hypothesis, and p star again as before, substitute all this. Here p star is 520 by 1000 because the number of boys is considered as p here. So 520 by 1000, so 0.52. We can see that the value calculated is 1.26. We can't do t alpha by 2 here. This is 1% significance level. Alpha is 0.01. It may be given in the question. Yes, alpha is 0.01. So it is 2.58. But see that 1.26 is less than 2.58. We cannot reject the hypothesis. We have to accept the hypothesis, means that hike of 500 to 520 is insignificant. There is no reason to accept and there is no reason to reject that hypothesis boys and girls are equally born in a week. We can say that even though there is a hike of 500 to 520, boys and girls are born equally in a week. Next is again a case of test for proportion as a specified value. This is a right-sided test. That is the suspicion is the superiority of the new drug established. Say that is p equal to 0.80 and a sample of 120 cases, 104 effective. So is there any reason to say that the new drug uh, superior to the old one? So p equal to 0.80 was the established value. So p greater than 0.80, right-sided test. So calculate the value of t. We can get it as 1.918. So right-sided test. So t greater than t alpha. The critical region appears only in one side. So t greater than t alpha. So this point 1.918, the value 1.918 calculated from the sample is greater than 1.645. So we accept this p equal to 0. No, we reject p equal to 0.80. I'm sorry, not accept. The value 1.918 is greater than 1.645. So we reject at 0, means that superiority of the new drug established. That means greater than 80 has to be accepted. Now comes the case of equality of two population proportions. We have two samples. One is 1,200 doses manufactured by a factory in June. Of them, 120 were found to be defective, and the next month, July, they manufactured 150 doses. Of them, 100 were found to be defective, and we concluded that there is no significant difference in the dose manufactured in June and July. So the null hypothesis is P1 equal to P2 versus P1 not equal to P2. It's again a two-sided test. And the sample proportions P1 dash and P2 dash are determined using these values 1200 and 120, 1200 and 100. And there is another thing we have to estimate using the sample data, that is P star and Q star. P star is N1 P1 dash plus N2 P2 dash by N1 plus N2. Substitute all these. P1 dash is X, P1 dash is 1, that is P1 dash equal to 120 divided by 1,200. That is the proportion of the first sample. Likewise, the proportion of the second sample, that is P2 dash. P2 dash is equal to 100 divided by 1250. So these are the proportions of the first and second samples. Now using these values, we can substitute here in the equation of P star. We estimate P star using this equation. So it is 0.102. So substitute all these things. Q star is 1 minus P star, that is 0.898. So we get 1.639, and this is a two-sided test. So this two-sided test means the critical region has to be split into left and right sides to separate sections. Here 1.639, the value of the statistic calculated based upon the sample, it is less than 1.96, or it lies between these two. That is, we have to say that the proportion of defectives not significantly different. So the performance of the manufacturer in June and July, uh, defectives not significantly different. Now next question is, sample of 628 men from town A, 379 are found to be smokers, and another town with 943, 415 are smokers. Suppose that the data do not have differ significantly with regard to smoking. So if you treat P1 and P2 are the uh, proportions of the persons smoking, or proportion of smokers in town A and B, we have to examine whether P1 equal to P2, and here P1 not equal to P2. That is the test. That means that test is two-sided. Again, the statistic is this. Here the proportion P1 proportion of smokers from town A, P2 proportion of smokers from town B. So this is about the equation of the statistic. We have to estimate P star based upon this. Here P1 dash is 379 divided by 628. That is for the first sample proportion, and for second sample proportion, P2 dash is equal to 415 divided by 943, because out of 943 persons drawn from second town B, 415 found to be smokers. Out of 943, 450 here. So P2 dash second sample proportion, and this is the first sample proportion. Substituting all this, we get P star as 0.505. So Q star is 1 minus P star. Substitute all these things here. So we get the value of T from the equation 6.26, and this is again a two-sided test. Therefore T alpha by T is 1.96. So 6.26 is greater than 1.96. And we rejected 0, means that the two towns differ significantly with regard to smoking. The difference we found in the proportions is significant with regard to smoking. So these are the various questions related to large sample test, the 4 test procedures in large sample test. So we have more examples in this section again. We will try to answer yourself. Thank you.